Hello dear students, this is Mr. Muhammed Azeez. In this lesson we are going to start chapter 4, section 4, which is about curve sketching. Curve sketching is a very easy topic, and every year it has 1 or 2 questions. Let's begin. We have some unordinary curves here, unlike the fundamental functions. This is the way the book suggests, but since the Wizari exam is multiple choice, we are not going to follow this way, because we are going to find everything we studied so far. So here, just cross out this page so you don't study it by mistake and waste time. Supposedly we have to find all of these things to create a perfect graph like this. But we don't do it because Wizari exam is multiple choice. So for multiple choice we use point plotting, or sometimes we use vertical or horizontal asymptotes. Let's begin. There are 2 types of questions. We either have one function and 4 different graphs, like this example, or we have one graph and 4 different functions. In the case when we have one function, we get points from the function. In case if we have one graph, we get points from the graph. Now, point plotting is about input an x value, find the y for it. Now I want to find f of 0. Why 0? Because 0 is too easy to calculate. It's my choice. I can find f of 1, I can find f of 3, 4, whatever makes the function not undefined. Now put 0 in place of x, we have 0 squared minus 9 over 0 squared minus 4. Using calculator, result is 4.5. Whenever you make some calculation like this, just turn to a point. X was 0, y is 4.5. Now look at the graphs. Point 0, 4.5 is on the graph of A. So option A stays. But 0.04.5 is not on the graph of B. This is negative. I have positive. B is directly out. 0.04.5 is on the graph of D. So option D stays in the competition, while option C is out because 0.04.5 is not on the curve. Now I have option A and D left. This time I need to choose another value like 1, 2 has no graph here, 3, 4, 1, 3, 4, the negatives, these are all good values for point plotting. Now I'm going to put 4 in place of x. I'm going to have f of 4 equal to 2 times 4 squared is 16 minus 9 over 16 minus 4. Result using calculator is 1.60. Now turn this to a point. X is 4, y is 1.16. The point 4 and 1.16 is not here. This point is less than 1. This dashed line is on 1. See, this point is below 1. Since it's below 1, it's less than 1. While I need something more than 1. 1.16 is around here. It's more than 1, less than 2. So option A is out. Now look at D. This point is 4. The x of it is 4. And the y is 1.16. How do I know it's 1.16? I cannot tell exactly, but I know it is above 1. This line is 1. Since this point is slightly above 1, that means it's 1.16. So D is the right answer. What we did here is all written, and it mentions that why D is the right answer. Just the way we did is explained here in details. Another example, again I have a function and 4 different graphs to match. Alright, I begin with f of 0 because 0 is very easy to calculate. F of 0 will be 0 divided by 0 plus 2. That is 0. So when x is 0, y is 0 as well. Point 0, 0 is on graph of A. It is on graph of B. It is on graph of C. So 0, 0 is not a very good point that I can make the final decision with, but it helps. Remove D. D is not on the point 0, 0, so option D is out. Now, I'm going to put 2 in place of x and see the result. F of 2 equal to 2 divided by square root. 2 squared is 4 plus 2. Let's find the result. The answer is 0.81. Yeah. 2 divided by radical 6 is 0.81. Let's simply say 0.8. Make the calculation point. X is 2, y is 0.8. The point to 0.8 is here. See this point, it's below 1, so it is 0.8. B is the right answer. While for A, the point to 0.8 is not on the graph. At 2, the graph is negative. We don't want this. And C, the same. At 2, the graph is like negative 1.67. Don't care. So B is the right answer. Now we have matching f to f prime. If we want to match a function to derivative, for the function we look at increasing, decreasing. For the derivative we look at positive, negative. Now look at this. This is a linear function. The function is always decreasing. So the derivative must be always negative. The function is linear, so the derivative must be constant. Derivative is always 1 degree less than the function. This function is x power 1. It is linear. So derivative will be constant, and graph of constant is a horizontal straight line, which is D. So number 1 belongs to D. It is a horizontal straight line that is always negative. This matches the description. Now let's look at the other graph. Here, these two waves, let's compare them. So whenever f is increasing, f prime must be positive. Look at this. If this f is increasing, or let's begin at 0, it's decreasing from 0 until pi over 2. The derivative is negative from 0 until pi over 2. This is pi over 2. In the exam, the graph will be much clearer than this. After the decrease, there is minimum. Minimum on f makes f prime 0. Makes f prime x-intercept. After the minimum, there is increase, and increase on f makes f prime positive. Never think like f is increasing, f prime is also increasing. There is no such thing in grade 12. But there is f is increasing, f prime is positive. How do we know it's positive? Just because it is above x-axis, that's enough to say this whole section is positive. So number 2 belongs to graph of A. Now look at number 3. On the side it's increasing, on the side it's decreasing. Now look at B. On the side it's positive, it's above x-axis. On the side it's negative, it's below x-axis. This is the best match. The function f has no any critical or maximum or minimum. And look at f prime, it's not equal to 0 anywhere. These are getting close to 0, not crossing it. So number 3 belongs to B. Finally, number 4. Look, the graph is increasing from negative infinity all the way to 1. That means f prime is positive from negative infinity all the way to 1. At 1 there is maximum. At 1 it is x-intercept, means f prime of 1 equal to 0. When f prime is 0, f is critical. From 1 until 2, the function is decreasing. From 1 until 2, the function of f prime, the f prime is negative. It's below x-axis. So number 4 belongs to C. Now we have a very, very important question. Pay attention to this question. This is relating everything you learned in chapter 4, section 2. A. Firstly, on the graph, it's not written f prime. We don't know what is this graph, but it is given. The graph below is the graph of f. Write f here, so later you don't mistakenly think it's f prime. Okay, this given graph is f. And listen to this. How do we think about f? For which value of x, f prime is 0. So f prime is 0 at critical values. Critical value means maximum, minimum. This is critical. -2 is maximum. So from this, I know f prime -2 is 0. +2 is minimum. From this, I know f prime 2 is 0. And then it says positive, negative. If f prime is positive, then f must be increasing. If f prime is negative, then f must be decreasing. F prime is going to be positive from -infinity until -2, union with from 2 until +infinity. The answers are all available. F prime is negative from -2 until +2, because this region is the decreasing region. Now, part A finished. Part B is asking this similar question, but it is about concave, convex, and inflection. So this time it is about f double prime. F double prime is related to concave, convex, and inflection. For which value f double prime is 0? F double prime is equal to 0 if f has inflection. 0, 0 is point of inflection for this graph because it's located right between convex and concave. What makes f double prime positive? The interval of concave, which is from 0 to +infinity. What makes f double prime negative? The interval of convex, which is from -infinity until 0. What makes f double prime 0? Point of inflection, which is 0, 0. Point of inflection is always located between concave, convex. This is concave, concave, and this is convex. Now part C. Part C is very, very important. It says f prime increasing. If you remember, we had a very easy expression saying if f prime is increasing, that means f double prime is positive, which makes f concave. Now if I want to find f prime increasing, I need to look for concave. Interval of concave is the answer of part C. Interval of concave obviously is from 0 until +infinity. So the answer of part C is 0, +infinity. And finally part D, for which value of x is f prime minimum? F prime minimum, when f prime is minimum, f double prime is 0. We studied this. If f is minimum, then if f is minimum, then f prime equal to 0. What if I add a prime here? If f prime is minimum, f double prime is 0. And when f double prime is 0, we don't stop here. That is inflection. So point of inflection is where f double prime equal to 0. And when f double prime is equal to 0, f prime is minimum or maximum. Here it is minimum. Why? Because this side is convex, means negative. This side is concave, means positive. Negative is going down, positive is going up. Between them is minimum. Even if the question doesn't tell us minimum, we can tell it is minimum by writing the sign of f double prime. Because when you want to find minimum or maximum for f prime, we are looking at the sign of f double prime. So that was the important question. Let's write a note here. It is the second time we write this note. Remember, point of inflection of f is going to be critical for f prime. Simply, point of inflection on the graph of f is going to be either maximum or minimum for f prime. That's a great note. These are also point plotting, all easy stuff. Point plotting, by only plotting the points, you can find which point is the right one. Question 18, is it possible for the graph of a function to cross its vertical asymptote? The answer is no, because vertical asymptote is based on undefined. If a function wants to cross vertical asymptote, the function becomes undefined, then we will get no solution. But is it possible for a function to cross horizontal asymptote? Then this answer is yes. Horizontal asymptote is the result of limit. It has nothing to do with being undefined. Well, some functions can cross their own horizontal asymptote. That's fine. Here, this question, if I want to find vertical asymptote, I make denominator equal to 0, and by taking denominator equal to 0, x minus 3 equal to 0, x equal to 3. When we want to find vertical asymptote, we need to test this x with the numerator. 6 minus 2 times 3 is equal to 0. So 3 makes the function 0 over 0, and 0 over 0 is not vertical asymptote. And if we simplify 6 minus 2x with x minus 3, we can simplify it like this. Simplify this. No, that's not question 20. Question 20 is below. This is an example showing that functions can cross horizontal asymptote. And here is the answer of question 20. If we simplify, we can take 2 as common factor. Then we will have 3 minus x up and x minus 3 down. They are not identical. We can take a negative as common factor in the numerator as well. Then the x is negative becomes positive. The 3 is positive becomes negative. Now x minus 3 crosses out x minus 3. After simplifying, the function becomes constant. And constant function does not have vertical asymptote, as simply it does not have any denominator to be equal to 0. This note is a very good note. Whenever you see a constant next to a fraction, that constant is directly horizontal asymptote. And if you want to find slant asymptote, it's usually written as a linear function next to a fraction. Then using this note, we can solve these two questions. A vertical asymptote at 5 means if I put 5 in place of x, I'll get 0 in the denominator only, not in the numerator. Horizontal asymptote equal to 0 means the degree of up must be less than degree of down. And then the same thing asks for slant asymptote. We just tried the linear equation next to the fraction we wrote in question 21. These are the answers. 1 over x minus 5 has vertical asymptote at 5, and it has horizontal asymptote at 0. And if we just write the linear function, 3x plus 2 next to the fraction, this linear function is slant asymptote. And here we have three functions. Which one is f, which one is f prime, which one is f double prime. Highest power is x power 2, that's f. Take one derivative, it will be x power 1, which is linear. The linear is f double prime. And derivative of linear is constant. Sorry, that's f prime. Derivative of f prime, derivative of linear is constant. So the constant function, which is a horizontal straight line, is f double prime. Very easy. And again, we have graph of f and graph of f prime to match. C, that's only for a quick review, refreshing the knowledge about f and f prime. If f is increasing, f prime is positive. When f is maximum or minimum, f prime is 0. When f is decreasing, f prime is negative. F is minimum, f prime is 0. F is increasing, f prime is positive. F is maximum, f prime is 0. F is decreasing, f prime is negative. Easy. Okay. This question. That's a very good question. It's been a long time. This question was not, has not been in Wizari. Last year there was a question in Wizari that needed the note that solves this question. The note is, the question says f prime less than 0. F prime less than 0 means f prime is negative. And whenever f prime is negative, I know f is decreasing. If f is decreasing, I can just graph a very simple decreasing function like this. This line is decreasing and mark until from 2 to 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now the question says, explain why f of 3 is greater than f of 5. Simply, f of 3, 1, 2, 3 is right here, while f of 5, 4, 5 is right here. Which one is greater? This has a higher y value, so f of 3 is greater than f of 5. There could be another way of asking the same question, which is like f of 3 minus f of 5 is greater than 0. That means f of 3 is greater than f of 5. When we subtract, we get a positive result, and positive is greater than 0. There could be like, which of the following is true? You have this and you have some others, like f of 5 minus f of 4. Originally, this is less than 0, but if we say greater than 0, this is true, this is false. There could be a question like f of 6 plus f of 3 equal to negative, something like this. So remember, this could be in the inequality form like this, or like this. The most abandoned question in grade 12, not very important, but the only question that highlights periodic. A function that is repeating the same curve is called periodic function. And how long it takes to complete one n shape? For this question, it's n shape, starting from here until here, it is n shape. After that, it keeps repeating the same n shape. That's the same n shape. Change the color, same n shape, keeps going. Each of these is called period, and each period takes 2 units. When in part B it says what is the period? Period is equal to 2, because each period, each wave takes 2 units. Then in part A is about symmetry. This function is odd. It's very obvious. This curve is up, exact same curve is down. This function is odd. Since it's periodic, means it keeps going. Since it keeps going, it's identical on both sides, but any curve that's up on the right side, same curve will be down on the left side. That's enough evidence to say the function is odd or symmetric with respect to the origin. And then it says identify local extrema. Extrema means maximum or minimum between -1 and 1. Between -1 and 1, -1 is right here, 1 is here. Between -1 and 1, there is this maximum. and there is this minimum. The maximum we can expect the x value, that's 0.5, and the minimum is negative 0.5. Then it asks for point of inflection. Point of inflection between 0 and 1. Between 0 and 1, 0 until 1. It's one wave and it's only convex. If a graph is only concave or only convex, it has no inflection. But if we extend the interval, like from 0 until 2, yes, there is one point of inflection. But since 1, according to the question, says restrict your answers between 0 until 1, 1 is not officially located between convex and concave, so it's not considered like point of inflection. 0 as well, because they are the end and the beginning of the interval. So the two ends of the interval cannot be inflection, because inflection must be located between concave, convex. Yeah, that's the end of section 4. Thank you so much for watching. I hope you find the videos useful.